So our next topic is rocket equation, motion of variable mass system. Motion of variable mass system. So here fundamentally what we have seen earlier is the mass in Newton's laws of motion is a constant. F is equal to dv by dt. This can be written as d by dt of mv, mass and velocity, which in turn will become mass times dv by dt or ma. So mass is a constant అనేది స్టార్ట్ అయింది న్యూటన్స్ లాస్ ఆఫ్ మోషన్ లో. అండ్ the first conflict that comes here is rocket equation. అందులో ఏమవుతుందంటే some part of mass is ejecting out, then what happens to Newton laws of motion is a discussion. Okay, right? So I'm considering a variable mass system. So let's say m is the mass of rocket plus fuel and it has an initial velocity v. M is the mass of rocket plus fuel with initial velocity v, and a portion of fuel is coming out with a relative velocity. So let's say this is delta m or dm, and this is m minus dm. So dm portion, a small portion of mass is ejected with a relative velocity v1. So both are moving forward, but this is traveling with a velocity v relative backwards. And suppose if this is traveling at a speed of 10, this is traveling at a speed of 6, then relative velocity between these two is 4 units backwards. So like that, this is the relative velocity between those two. So then what is the actual velocity? So this velocity is v minus v relative, and here the velocity is v plus v relative. Okay. So now we are going to apply Newton's laws of motion or change in momentum, because we try to find out this change in momentum. Okay. So we are considering the whole thing, rocket plus fuel, as a single entity. So initial momentum ఏమవుతుందంటే mass into velocity. Final momentum so mass into velocity what do you get if we simplify this? ఏమొస్తుందంటే final momentum is mv plus m times v relative minus dmv minus dm times v relative plus dmv minus dm times v relative. అర్థమవుతుందండి. సో దీనిలో వచ్చిన చేంజ్ ఇది v minus v relative. So the velocity of heavy object increases by a small amount. I call that as dv. So what you get? So it is v plus dv mv mdv dmv and dmdv. So these are the equations. Change in momentum. Change in momentum ఏమొస్తుంది? Difference of these two. Subtract చేస్తే ఏమొస్తుంది? mv gets cancelled. And I am assuming these two are very very small numbers. So product is even smaller. So I am neglecting this. So all other terms will get a negative sign. P final minus P initial. So I will be left with m dv and this dmv is getting cancelled minus dm v relative is equal to 0. Sorry, not is equal to 0. This is delta p. Delta p is mdv minus dmv relative. సో ఇక్కడ రెండు టర్మ్స్ 2 plus 2 టోటల్ 4 టర్మ్స్ క్యాన్సిల్ అయినాయి, ఒక టర్మ్ నెగ్లెక్ట్ చేశాను అంతేనండి. సో టోటల్ టర్మ్స్ అన్ని ఇక్కడ 2/2 4 plus 2 6 plus 1 7. Out of 7 I am cancelling 4 terms and neglecting 1 term. 5 होते करंट मिगिलिंది. The other 2 terms. So now I can apply Newton's laws of motion. What is that? dp by dt. dp by dt is equal to force external. There is any external force. This change should be equal to that. Same రాయాలండి. m dv by dt minus v relative times dm by dt is equal to f external. So what do we know from Newton's law? General Newton's law says this, right? m dv by dt is f external. మనకు తెలిసినంత వరకు ఈక్వేషన్ ఇదే కదా, ma is equal to force అని. ఎక్స్ట్రా ఏం వస్తుందంటే v relative times dm by dt. So that is the extra term you are getting because of this ejection of mass. ఆ మాస్ అనేది మారటం వల్ల మనకు వస్తున్న ఎక్స్ట్రా టర్మ్ ఏంటది? v relative times dm by dt. Okay, so we call that, so m dv by dt is equal to f external plus f reaction. So this is the total equation I am writing here. So the reaction force is given by v relative dm by dt. v relative dm by dt. So when there is no reaction force, Ma is equal to external force. If there is an additional reaction force, that term will add. That's all the basic rocket equation. So we'll apply it to the actual situation. What is that actual situation? So there is this external force. Rocket cave జరుగుతుంది external force అనేది mass times gravity అవుతుంది. That too downwards. Since rocket is moving upwards, so ఈ rocket upward వెళ్తూ ఉంటే there is a downward gravity. దాన్ని ఏం రాస్తున్నారు? మైనస్ mg. So the total equation now becomes what? M dV by dt is equal to V relative dm by dt minus mg. That is the equation. Now I want to calculate the velocity of the rocket. What is the final velocity is the question. అంతే కదండి, రాకెట్ ఫైనల్గా ఎంత స్పీడ్ రీచ్ అయింది అనేది తెలిస్తే మనకి దానికోసం ఎంత ఫ్యూయల్ ఖర్చు పెట్టాలనేది తెలుసు. ద ఈక్వేషన్ ఫర్ ఫైనల్ వెలాసిటీ, దీని నుంచి v బయటకి తీసుకొని రావాలి. సో వాట్ ఐ హావ్ టు డూ, ఐ హావ్ టు గో ఫర్ అన్ ఇంటిగ్రేషన్. దీన్ని ఇంటిగ్రేట్ చేయాలి. సో హౌ డు యు డూ దట్? సో dv ఈజ్ ఈక్వల్ టు minus v relative by m dm minus g times. So I'm cancelling dt, or I'm multiplying with dt by m. So dt by m to multiply the same as you will be left with dv v relative dm minus mg dt. m పోతుందా? g dt. Yeah, m is also this. So I'm adding a negative sign here. ఇక్కడ వరకు పాజిటివ్ ఉంది. Add negative sign to dm. I'm adding negative sign to dm just to tell that mass is reducing. Mass అనేది తగ్గిపోతుంది కాబట్టి dm is a negative number. So to represent that, I'm adding a negative sign there. Okay. So now if you integrate that, ఏం చేయాలంటే integral v0 to v minus v relative by m integral m0 to m dm minus g. So the variations are velocity changes from, time changes from 0 to t, mass changes from m0 to m, velocity changes from v0 to v. Okay, so if you integrate that, what do you get? One by m, so this is 1 by m. So 1 by m की integration ఏంటంటే log m, log base ని నేను ln అని రాస్తున్నాను, log m. minus g times t 0 to t. So v minus v0 is equal to minus v relative log m minus log m naught minus gt. Total v is equal to v naught plus v relative. So I'm taking a negative sign outside. Log m naught by m. So that is the final velocity of the rocket. And if you integrate it further, you will get maximum height reached by the rocket. So that is given by v naught t plus v relative log x की डेरिवेटिव ఏంటంటే x log x minus x. Sorry, integration. Integral log x is x log x minus x. So m naught log m naught minus m naught minus m log m plus m minus half gt square. That is the maximum height reached by the rocket. And this equation is called Charles. Tsiolkovsky rocket equation. The maximum height reached by the rocket. So ఇప్పుడు దీనికి ఏమేమి ఇన్ఫర్మేషన్ కావాలంటే all we need to know is the initial velocity, time of travel, relative velocity and the remaining mass. So with that you can calculate the final height reached by the rocket. And if you draw a graph between delta v by v relative m naught by m, you get a curve like that. So velocity and mass ratio, that's all. So in this overall we have calculated the initial mass and velocity of the rocket, final mass and velocity, calculate the change in momentum, dp by dt equated to external force which is minus mg, and calculated final velocity and final height of the rocket. That's all.